Good morning. How are you? Fine. This is group 1. We have Hamid Senokwe, the leader. What was the classmate?
You said something.
We are presenting something about refrigeration and air cooling. So I started by defining what a refrigerator would be. Simple cooling appliance comprising of summarily insulated compartments and heat pump. The refrigeration process is just a process of taking away heat from the substance you want to cool. And this is just a brief history. As before mechanical refrigeration were introduced, people could use ice, snow, either collected from the top of the mountains and put somewhere to cool their stuff, what they wanted to cool. And the first cellulars were holes dug in the ground and lined with wood and straw, and packed with snow and ice. They could dig some small holes, then put ice inside, and then on top of them, they put there what they want to make it cold. And this is how a refrigerator came about. In 1748, William Warren at the University of Glasgow was the first person to make that official demonstration of the refrigerator. Then in 1805, an American inventor, Evans, also designed the first refrigeration machine to use a liquid as a refrigerant. In 1834, the first practical refrigerator came into existence by Jacob Perkins using vapor in the compression cycle. In 1844, American physician John Gould built a refrigerator based on Evans' knowledge. So he used what someone had invented and he added on. In 1913, refrigerators for home and domestic use were invented by Fred W. Wolf of Fort Wayne, with a model consisting of a unit that was mounted on top of the ice. So the model was you could put your ice below and then you put that substance on top of it to be cold. The introduction of furan. Furan simply refers to chemical compounds used as a refrigerant in refrigerators, and they are supposed to be non-toxic. Because if they are toxic, then they will have harmful effects to people using them. So in 1930, 1920, in that range, we saw people using furan. They were good refrigerants, and refrigerators by then became somehow powerful, and we see the first industry to use the refrigeration was the refrigeration process, or to apply it was the brewing industry. That was an industry in the United States of America, and they only realized that when people from Germany came to USA and they found things that were from the refrigerator were better. They were tasting better than what they used to have at home, and they also decided to adopt that kind of knowledge. The second industry to use the knowledge of refrigeration was the meat packing industry in Chicago. Because they had that problem, they could only keep meat when it is winter period. Beyond that, they couldn't manage to preserve their meat for some days. So in winter, people could not feel like people feel this side. So they could wait for winter so that they have that good condition to keep their meat. as safe as for some days. Then the refrigerant technology quickly became popular in society, with refrigerators being used everywhere, and they were common as those people, because people can't go out without food. They have to prepare and eat. That's why when you go back to your hostel, every person at least has got a stove. So it is a very powerful need, and today we have as many as possible. So simply, the refrigeration operates on the following physics. The liquid is rapidly vaporized. The liquid the quickly expanding vapor requires finite energy. The vapor that is being taken requires energy, and that energy is going to be drawn from the substance you want to cool. Then that very substance you want to cool will lose heat, energy in the form of heat. As its heat is being absorbed, then that very substance is cooling. That's simply going to see. So this is the output of the refrigerator. So what you're seeing arrows going through an apple. We decided to use an apple as a simple demonstration. The one you're seeing in blue, that's the cold liquid, the refrigerant. That's the cold refrigerant passing all over our substance. And in this case, our substance is apple. You see, the blue one, the one entering, they are cold, and whenever they pass around, they try to draw that heat from the apple, and the apple will keep on dropping its temperature story by story. At the end, when the process is continuous, then we shall have our apple with the temperature we want it to have. So this is simply what takes place as it continues. You are seeing these arrows, they are showing you that heat is being drawn from the apple. So that process must be continuous so that your temperature is reached, the temperature you want to attain. And that is the inside part of the fridge. You've seen the behind part of the fridge where we have the cooling fins. This black thing you see here, it is a compressor. We shall see its use. And that's basically what is inside the refrigerator. You've seen the so-called steps. These are steps, and each step is meant for its purpose. So the whole process of refrigeration is based on what you're going to look at as the throttling tube. The throttling tube, this is a tube that does a lot of work in the refrigerator. Without this, then we couldn't have used the refrigerator to cool our substance. And this is what happens. That's called the throttling tube. It is a capillary tube of very small dimensions, and the other blue arrows we saw at first. Now this is the other arrow arriving, because we are seeing the blue arrows and passing all over the apple, but as they could pass all over the apple, their color could change. So at this point, we have the arrows that kept on absorbing temperature from the apple. At this point, this refrigerant of ours, it is a very high pressure liquid with very high temperature, because it has been drawing temperature from an apple, and then the temperature is going to be cooled as it passes through the throttling tube. And this is what happens. At that point, you see we have a high pressure liquid, and the temperature is also as high. These are small dimensions of the throttling tube. So what will happen, the pressure will drop. As this arrow shows you that when it reaches here, the other heat is going to be cooled down. When the heat cools down, so the pressure will. Before that, you are seeing that, you see that one passing through. So this is how the refrigerant, the other high pressure liquid, will go through the throttling tube. As it goes in the process, you are not in something, there is a change in color. This one, there is a change. Originally it was a bit something like purple, but this time it's turned into blue, meaning there is a change in its temperature. Are you getting me? So it will continue, and at the end of it, you see it is turned into pure blue light. It was entering when it was going to pass over the airport. Here it showed here at the beginning there, when it was somehow purple, it was at 45 degrees. It is very high compared now when it's at negative 20 degrees Celsius, meaning it has dropped. So we can repeat this process several times, because now what we have at this point, we have a very low pressure liquid with a very low temperature, which can as well go back and pass all over the apple and draws more heat that has been left. So when we make this process continuous, in the process we keep on cooling our substances in the fridge. So the next step at this point, the liquid will move through this tube. As it moves, then it will go through the cooling the tubes. So as it goes, you see the movement. When it is going like this, it is absorbing more heat from the substance you put in those steps. It continues until the whole refrigerator is. So at this point, it is back together, point of a high pressure liquid, because it has been absorbing heat from the substances we wanted to cool. And at that temperature, at that point, its temperature has been increased again. So we are now going to try to change the low pressure vapor to high pressure vapor again. As well, it is at a certain temperature, but that temperature is not enough, and not the temperature we want. And to increase the pressure, to change it from low pressure to a high pressure liquid, there we're going to make the use of a compressor in the refrigerator. So in the process of changing this, we shall use the compressor and compress that vapor. And in the process of compressing, you know from your physics, when you compress something, what happens to the pressure? It increases. So we shall again generate that pressure. And when the pressure increases, the temperature will also increase. And when there is that increase, so we shall go back to our initial stage at the throttling tube with a high pressure liquid, high temperature liquid, and we shall go back to the process. So that's what happens. So at that point, this pressure is reduced. Okay? So we want it, now it is being raised after it has passed through the throttling, the compressor. As it was entering, it was somehow low, when it was still very low, and after it has been increased, it is now at 80 bars. And here it is the high pressure I was talking about, and it continues. When it continues, it will be again back to the throttling tube, and then the process will continue, go on. So, the demonstration shows this is the process I've been talking about. I've explained that one, and these are just a summary of what takes place in the refrigerator, which is not far from what I've explained. So that's how simple the refrigerator works, and that's simple physics. Air cooling. Simple air cooling. It's a method of dissipating heat. When you have a lot of heat in the room and you want to take this heat out, then you need an air conditioner. It has got fans. Those fans can either be, they can be blown onto or into damping. If you want to cool the surface, then it will go all over the surface. If you want to cool the inside, something inside, then you will have to go inside. And it is all about increasing its total surface area. You know, when the surface area is very big, then we have very many molecules escaping, and then conditions will come down just to drop. And the best concept started all the way from Egypt, where reeds were hung in windows and were most stained with sprinkling water. The evaporation of water cooled the air blowing through the windows. So that's the simple technology people from Egypt used to have their rooms with good air conditionings. The process almost made the air more humid. So the trickling water dropped in the reeds could make air more humid, which could be beneficial in the dry desert climate. So some of you are from desert areas who could apply that knowledge and save their villages. So that is also a brief history of it. In Rome it was used. Then in Paris, Cassia was also involved in the use of cisterns and wind tower to cool the building during the hot season. So these are the technologies people have used to cool their buildings. The modern air conditioning emerged from advanced chemistry during the 19th century, and the first large-scale electric air conditioning was invented and used in 1902. That's when the first air conditioner was made, and it was made by an American inventor, Wills Carrier. So a very large number of industrial processes use air. So I think that air conditioners are very good and are very important in industries, for there is a lot of heat and you need to blow that heat outside, because if it increases it may lead to fire breakout, and which dangerous are. So we need that constant cooling in industries. So it can be either used directly or indirectly. So you see, I think it's a common knowledge used in the rooms to cool the rooms down, and often the air has been cooled by chilled water and then heat transferred into the medium. It is transported outside. This is the simple mechanism and how it works. How does it work? It's not so different from the refrigerator we have seen, but as you say, this is also the compressor, and also the compressor within itself. And you see what will happen. This is heat. It's not seen clearly, but this is heat removed from the indoor air. You're seeing these are the fans, and you have seen the importance of the fan is to create that large surface area and you keep on blowing that hot air. You know what happens when you're in a certain room? The hot air will raise and then the cold air will drop, because it has got the density is greater than that of hot air. And what will happen, as the fan is blowing away, the other one with less density will be taken out of the room, and that's how our air conditioners work based on that simple knowledge. So these are the things what the compressor does. I've said it. And we look at the advantages of refrigerators as we conclude the presentation. Allow extensive capacity storage of food. We all know that without a refrigerator, then we couldn't keep food for some days to be another day. It would always go bad. They preserve processed products to be used at a later time when you need the rises. Like you can do something today and you want to use it today and after 1 week, but you don't know how to keep it. So the refrigerator can help you keep that. And these are the general try to do the right things, because when we talk of the product, we mean very many things. When we talk of food, we mean a lot of food. And the disadvantage is it is power dependent, and that's the most difficult, the biggest challenge. It is power dependent. Without power, I think you have difficulties to use it. Maybe you have to adopt the other method, where you go to the top of the mountain, collect your snow, put it somewhere, and put, which is somehow hectic. Few of us access mountain. The initial costs are very high. Not every person can afford a fridge, though all we want to benefit from it. Too much of it leads to health problems. You all know that. when you take a lot of old things, then you maybe suffer from indigestion. You know, the food must be at its temperature in order for enzymes to act on it. When the temperature maybe have dropped, the enzymes are going to be denatured, and then we shall have complications. So that's the biological effect of using refrigerators. That's all. Thanks for listening.
Thanks, Maxwell. I know there are people who are burning with questions. So these refrigerants, what is their most disadvantage?
The most
disadvantage, according to the current trends that are happening in the world today. Some of them is, I don't know, which gases are used in these refrigerants?
The refrigerants. We have furnace.
What?
Furnace.
Come again?
Furnace.
How is it pronounced? Flame. Okay, so e.g.
We have
you heard about climate change? Do you have an idea about climate change, global warming? You heard why the government was refusing the old fridges to be blown about?
yes.
Because in the compressor we use that gas. The gas which is moving around is the family of the methanes. Understand? And when it goes up in the sky, it imbalances the normal global warming the greenhouse effect. So when there is an imbalance, in other words, what happens? How many of you did environmental physics? Yeah, the greenhouse effect is that when it shines, the sun will always produce the heat. If the heat comes and lands on the clouds, part of it will be absorbed by the clouds. If the clouds are bright enough, some of it will be reflected. Then when it is able to go through, some of it reaching the ground will be absorbed by the ground, so the ground becomes hot. Some of it will be reflected as infrared and goes back as heat. Then again, when it goes to the blanket of the clouds, some of it will be reflected back as infrared, which is the heat, and some of it will be absorbed by the clouds and remain there, or some of it may now disappear to the skies if it is not cloudy. So there should be that balance, that everything should run like that and we get some good temperature. But if you release carbon dioxide by burning stuff, or you release this methane from such used up things, the methane up there will absorb more heat and retain it. And because it is not normal, because for the clouds, once it rains, then there is no more, nothing should. That's why when it is about to rain, you feel hot, you sweat, because whatever heat was coming down and got reflected as infrared, got housed in the clouds. So you start saying maybe it will rain. You start feeling the heat because it went and came back. So there came an imbalance. When it rains, then the clouds are all cleared out. When they get cleared out, now you feel some freshness because now the balance is good. Whatever is reaching down is reflected, goes away, disappears there, and the blowing of some wind is okay. So some of those gases, some of these fridges are disguised because of that. But you guys may be having some questions. In other words, me, I'm happy that he's been a good student. He has attended almost 90% of my own viewings, and the way he presents his stuff is very chronological. I'm sure there are even my colleagues who cannot make it flow. I've been teaching them well. I'm teaching a bunch of members of staff from all over the university, almost all colleges, very early morning and very in the evening. And they still ask, what did you do to get a tab on a web page? So the flow of how he made his PowerPoint flow, make sure his demo is in his mind because he knew what was coming out next. to me is an encouragement. What I don't know is what these guys did. I wish I could give them a chance to explain something. Colin, can you go to the part of this one? I don't remember how it was called. This one. I want to ask you have a question?
I'm just impressed with I'm just wondering how did you get this?
It's a video. He got it, I think it is a video in VLC. He's playing the video, but that's why I'm saying that even when his video is playing, he made it seem like a PowerPoint presentation, and it would play and bring the things and work. It's a video which is in his work. So he knew that this will be this. That's what I want you guys to learn, that you may be knowledgeable about something, you may be having a proposal to the government or to an NGO or anything, but you reach there, you fit it with things. You start saying, we need to ban fridges, but you know they are not good here. But if you go and show them how they work, show them what is used in how they work, and say what they use is dangerous, we should ban them, everyone will go when he's comfortable. Yesterday there was a launch of a similar crank lamp in food science. The Germans were trying to market it. So at lunchtime I met one of my former students and some colleagues. So we were arguing, they were saying it costs 100,000. So they were arguing is solar really that important? I like solar, but I think it is also misguided. Because if you do solar, isn't it? Mm-hmm. Yes. So here is the question I want you to answer me. If we all said we are going renewable in terms of solar, and we plant trees and we stop using carbon dioxide, anything that produces carbon dioxide, our trees will grow, isn't it? Mm-hmm. And when our trees grow, our climate will change. It will start being cloudy almost all the time. True? Yeah. And then sometimes it will be raining, like the Congo rainforest. It is always cloudy, moist. Like in my district, those days it would be foggy until 10 a.m. and by 7 p.m. again you see some fog. So you would have the sunshine reaching your houses maybe starting at 11. And it will be as if it is morning because the fog is just going away. So how are you going to effectively use your solar panels in an environment which is cloudy, rainy all the time? Because you have now conserved the environment. You see my problem. The people who campaign for solar, they are doing it for a good cause. But then it will not work once what you are agitating for happens. Once the trees grow, once the rainfall comes, then your panel is useless. And nevertheless, they will continue saying so that maybe we can recover some deserts. So, questions, ask questions. But I'm impressed. I have now understood at least how my fridge works. I didn't care. I always just went there. And my fridge is just for storing. It's like a dustbin. When I eat bananas, the peelings of the banana is where I put in the freezer. Because I'm lazy, I don't know how to go and throw away the stuff. Because when I buy banana, I just keep outside so that it is fresh and sweeter. When I eat, I throw in the freezer. So now I know how it works. Next group is who? But Colin, bring here, yes. Can you tell us, can you come here and tell us how it works? He said it, now you know. So you can tell us exactly. I did not pick well how temperatures we are getting from 45 to negative 20 something. So can you have a floor and explain a little bit? You know, you students know how to gather up and say, you go and present it. And for them, they want the free credit. So just go there and tell us how, if you want help, he's there to help you. You tell us exactly that small process.
The throttling.
The throttling process. can use that thing and press that button in the middle to point for us. Yes, now tell us what is going on. You are presenting to us.
Maxwell has presented like using help as an example. Now from here, he was saying there when the temperature increases,
you can make it flow, start from behind, so as she is explaining, it will happen to reach there and then we will get the point. Yes. You can start explaining. The already thing is there. As it comes, we shall see what we are talking about.
you was talking of like that.
It is you now, not you.
According to that was over. The blue arrow was winning, it was being taken. And the red one, it was being absorbed.
So the apple absorbs heat.
Sorry?
The apple absorbs heat.
No. The other blue arrow was winning, the heat was being taken.
To where?
Being absorbed.
By
the refrigerant.
and then taken where? I did not know explaining makes me excited. Smiling. I think the purpose of cramping it together, yes, you can always get a lead in a sense, but also you should make sure that you own the work. Actually, before you come here for other works which will come up, you should own the work and you can present it to yourselves and make turns. One of you goes, presents, you critique, another one goes there, presents, you critique, and then you choose the best. But by the time you are presenting the work here, you should all be very conversant with the work. Get a point? Okay, so thank you. Yes, you have a question?
Thanks for your presentation, but I would like to know better because in our place, when I was there, we used to use those clay pots, putting their water, they boil it, after boiling, then they put water in that pot, it condenses in that pot, it becomes cold. Is that also refrigeration or?
That's what we looked at when I was giving the history, that people could go on top of the mountains, collect the ice, put it somewhere, and on top of that ice, put the thing they want to cool. That's the same thing they apply in the fridge. And I remember, if I recall very well, what they do at home is after preparing the water in the pot, we are going to make this pot sit. You have to put some small alcohol and then you pour their water, the cold one, that when it sits down, that it is being drawn from the pot into the ground in the process to go.
And that one was my household, my kitchen was glass thatch, so it is a bit cold.
And most likely when they are putting the pot, they look at somewhere in the corner. It means where there is no much light, it's in a place that
Okay, before you remove the thing, I would like to come. I would like, you see, he had to struggle looking for the video so that he plays the video. You can put the video within your mouth. You understand? So he will show me where his video is eventually, and then I will get, for example, he could have invoked the video on each of the slides. that talks about the that's one point I want to make. So which slide do you think? Okay, this one on the apple. So after, for example, this one, we could create a new slide, and we could say the demo. Okay, we are going to say demo of the cooling, and then we look for the video. Okay, so I'm going to look for this video, and could you tell me, show me where it is? Look for it. Which one is it? Okay, there. And then the video will come here and occupy this space. And then you ask whether it asks you whether you want it to play automatically or whether you want it to play on a click. It's up to you, depending on, you know, it is not good to put a video on a slide and before you try to explain it, it starts playing. But if you are good, if you are very nice, you've really mastered your thing, it's nice to put, so that when you go to the next slide, you are sure that you will start explaining. But there's times when you are still busy talking a lot of things, so you may say when clicked. And then you can expand your, when you are expanding, use these other corner buttons, and then you can finish the whole space. If you are if you want to be so artistic, whenever you are moving these figures in your PowerPoint, use Control and arrows to move those small steps. Now, you may want not to have white and then everything is black. So what you do, you can choose this part and say, let me first select this. I will arrange it on one. Then I will choose it to be white. Of course, it will disappear. But then I will choose the whole thing here and go to Format and say Fill, and I will fill it white, I mean black. So now everything has become demo in white and the box has become black. So I arrange it properly and also push it a little bit there and go to my video space, make it disappear there. So I now have, this is when I go to a full screen, I have a video inside there, and that's why I have that hand, and the screen is looking beautiful. So, like we came from above, and you have talked of the basic principles of refrigeration, and you just pass a quarterly period, and then this will take heat away, and then refrigeration in turn gets heated up, and then refrigeration turns, its heat goes up, because it has absorbed some from this object within your fridge, and then you say, now we are going to demonstrate how it works. If I had said automatically, now it will start playing. But on the click, you first give intro, so this demo will make sure that we understand. Oops, I should have. You say this demo will, I'm looking for the cursor. It will come, I guess. If I may go up a bit, first look for it. Yes, so I click and the video will start playing as a demo in the thing. So then you start explaining. So you did not need to go to the video and start playing it. He could now play it here. He explains how the heat is coming in. The red, as it comes in as blue, it absorbs the heat which was around the apple, and then it flows away. And if we enter into the inside, those other tubings inside take the heat, and they are meant to be filled so that the heat is either absorbed easily and given away easily. Then it goes to the other part, which I was telling how to explain first. And as it reaches here, it comes when it is hot, but leaves when it is really very cold, and the process goes on and on and on. This is how you make your PowerPoint so smooth, as if you have high technology. The only thing you have to know is that if you are going to put your PowerPoint on a flash, make sure the video is in the same folder as, your power point. Otherwise, you will look for the thing and you cannot get the thing. And once you have explained the video and the demo is now done, you go to the next slide and move on to other things. Get the idea? Now, PowerPoint the name is Powerful Points. Those of you who have attended my moon viewing, I don't have any points there. Ever seen any? I put one photo and then I talk for 30 or so minutes, or for 5 or 10 minutes on one photograph. So that's why I said you put both the write-up and PowerPoint, so that eventually I show you that, for example, he did not need to put all these 4 main components of refrigeration are these, and you just put a heading, components inside the refrigerator, and then you put outline, the condenser, compressor, evaporating and throttling device. Then you have to give powerful points. No one is interested in reading your whole stuff here. This is boring. If you were to present to some people, this should be in your mind. So when you talk of for effective throttling at the inlet, then you should say refrigerant should have high, you shouldn't have to say should have high pressure, which causes this, boiling point, this. You should just say one, refrigerant. Then you tell us what it is all about. They should be powerful points. Okay, now I think you have I have next group.
But I have a final question.
Yes.
Is the refrigerant a gas or liquid? And if it is a gas, which kind of gas they use?
It's a liquid, but it can be vaporized to a vapor and then turns to liquid again. So it turns around in states, gas and liquid.
Okay.
And you want to know example? What were we saying here? Where were you when we were talking about methane? So what is the other group? And how did you name your file?
That's your second.
Or you want to use your computer also?
Yeah, we're using our computer.
But is what you want to present the same as what you uploaded? Because I will judge you from what you uploaded.
Yeah, it's the same. You can put the relevance.
So you are which one? The lesson?
Yes.
Right. So unless if you are going to present in the shifts, others you have shifts. You're like wrapping the book. Okay, so whoever is wrapping should be don't exceed here, because my camera can only see up to here. Don't disappear from this. The vision of the camera.
Thank you very much. Good afternoon, everyone. With my group members here, the faces are not new. We are going to present about crop drying. And basically, we are in shifts. I'm requesting the people if you can stay a bit and also one. Yeah, I'm going to bring again with my colleague.
May I come?
And basically, tell these people what a crop is.
Yeah. Yeah, our crop is a cultivated plant. I think we've seen them before. If we have maize, that's a maize crop. We have beans, we have and other fruits. Those are just a cultivated plant.
Then drying Drying is just the removal of, you can call it moisture or any other solvent from crops. So that means crop drying is basically the removal of moisture from crops, depending on which kind of moisture you want, or for any other purpose.
So the drying of these crops, some of us in the villages, they start from the garden. Not like maize, you can't harvest raw maize. You have first wait for it to dry, but of course, we need drying at home also, because we cannot store it. We may evoke moisture and maybe it looks bad. So start from the garden, then continue from home.
Yeah, this is basically what we have been talking about. Then we also have methods of crop drying. We have natural methods and artificial methods.
So in the natural methods, we rely on the sun to dry our crops. Those are basically the natural methods. So, but the sun sometimes is not sufficient, like in the deserts, I mean in the cold places. When you come from mountain God, sometimes the sun may not be there for the whole day. So you have to resort to other things like roasting and all that to make things dry.
Thank you. And the major advantage of crop drying, of natural drying, is that it is very cheap. For example, here, this is a woman, and she's trying to dry some maize here. These are just plantation, and this one is natural drying because we are using sun directly from we are using sunlight to dry the maize. And we also have another one here. Hope you are all familiar with this. In Uganda, this is what they do. They first leave the maize to dry from the garden. Then after they come and remove the final product. Then there is this one also. I don't know whether it is clear to you. These are the women. And this is also natural drying because we are using sunlight direct. Only that this one is a bit more advanced. They are using a layer here, a material which cannot absorb moisture. That means this layer can also reflect some light. What is the implication? The implication is that if you're drying your material, the lower part will also be dried because this material is also able to reflect and absorb as well.
Yeah, to bring it to maybe our life for example, when we're still in high school, we make some aperitif, we boil the greens, dry them and crush. So this is how we can dry them, crush and go with them. So that you get your beans, then you get some powder. Because it's dry, there's no that you carry the fresh things. Carry fresh peas to school, there's no that you can store that. So you can dry them and take them to school.
Yeah, thank you very much. And another thing, you must be realizing that there is this part here. This is just the cover. So when the sun has gone away, you don't need to remove the things, depending on the environment, of course you are living in. So in the evening, you just come and cover, prevent moisture from going back, especially at night. Then you also have the artificial methods. For example, in Germany sometimes, or other European countries, it is very cold. Luckily, yeah, here in Uganda, we are just around the equator, so every day you're receiving, most of the times we receive sunshine. But in Germany, there is no way you expect them to dry using sunlight, because sometimes it's not there. We have to develop a new mechanism, that is artificial method.
So in artificial method, sometimes we just formulate something like an oven, then generate heat. We can generate it from maybe like electricity, and use fans to drive that heat into the oven. Put our crops like on top, push the heat under, then mix the moisture to evaporate from the crops.
Thank you very much. Then, how do you compare the two? You are saying you have the natural and artificial. The comparison is as brief as this. For natural, it can be done in two ways, whereby you just force moisture, hot air, directly onto crops, or you just put them directly to sunshine. Then for artificial, it utilizes heat drying followed by rapid cooling of the grain in the dryer before transferring to storage. It can be like a package.
So that's one of the artificial methods. They have organized, they put solar panels in the building. We know that solar panels are very good at absorbing the solar energy. So when they absorb and then re-emit them into, maybe put the crops inside, you can show. Our crops are inside under the building. This one absorbs and re-emits the heat into the building. So that the temperature of the heat is extraordinary. It's not that ordinary temperature. So that if the crops are inside there, they can easily dry. Instead of putting them outside, maybe rain comes, you're still in the why you said before you rush home and remove the things, they already have been spoiled by water.
Yeah, to use more light on this, I wish to explain the mechanism that takes place in here. Basically, these are solar panels, and these solar panels, we are using them to generate heat. But how is this heat transferred to our crops? In between the layers, we are having a layer which is composed of air. This air is always, it is thermal, as in it is heated. When it is heated up, it can be taken away by using like a fan that is forced, like before we had looked at forced movement, whereby you just use a fan to blow away that hot air onto your crops. Then we also have another one here. We are having this material here. This material is a transparent material which can allow solar radiations. So you just need to put your crops inside, then you cover it. What is the use of covering? Covering serves two purposes. First, we are not so sure. This method you don't need to just be there every day. You can just put your crops, you cover it, then you go away. When it shines, it is able to, your crops are able to dry. And secondly, you're also not so sure. What if you had put your gin nuts and their mark is coming? That means if it is open, they will be eaten. That is the second purpose.
Advantages?
So, on part of advantages, we have in our colleagues. Let them share with you what they have.
I'm here to present to you advantages of crop drying. The first one we have for easy preservation. Like the way that man said to me, like the way when we were still in secondary, we used to dry some dough, so-called dough, green. You keep it for when it's dry. You keep it. You can take it to school. Maybe when you're enjoying your beans, you can always have it appetizing. The second one, we have some crops cannot be eaten raw. I can give you an example of millet, rice. Yeah. Some of those crops you can't eat them when they are raw. Yet needs hence need for drying. We have another one, drying greens, reduce or eliminate spoilage in storage. For example, millet, beans, like when you harvested them, obviously you then you keep them when they are fresh, they will have to get destroyed. And like when you dry and you keep them, let's say a granary, stores, you can always keep them for long. Then we have another one. It may improve market grade and accessibility for green. Like an example of coffee, we've always like a well-trained dried coffee will always attract more customers. Market when you market it. You can't always compare yourself if your coffee is not well dried to that one who has dried it well. The market always attracts the customers
a web-dried problem. We have another one for easy processing. Let's say maize. If you take your maize for dried meat, it's more easy to get processed compared to that one which has some moisture, fresh meat. Then it reduces losses from wildlife. Like when if you are to leave them in the garden, they would get destroyed by the weather condition, let's say, or eaten by the wildlife, man. That's all.
Now I'm going to discuss the disadvantages. It requires extra capital for you to dry your crops, more especially when we want to set up the mechanism for drying the crops. For example, if you want to dry your maize, you need to get those people who can help you, maybe to transfer them from the store to the ground where you want to dry them, which requires some capital. It requires extra labor. As I have told you, in capital, we require to pay the laborers. Okay. So for you to dry your crops properly, for example, when you saw the picture where people were drying crops. Now, if you want to dry them at a large scale, it requires you to put in much labor. And number 3, it requires some experience to operate effectively, more especially during artificial drying, where we need to bring in fans to pump the air into the crops in order to drive away steam or to drive away moisture from the crops. If you are not an experienced person, your crops may fail to dry properly. It may impair quality of malting, but if not operated properly. This malting, those who are Uganda, malting okusumbuka. When crops are over dried, in quotes. Okusumbuka. That is to molt. And now, for example, if you are drying your crops, if they are over dried during the time of germinating, they may fail to do what? To molt. Is it okay? So that is that. Thank you for listening.
There is nothing more apart from just trying to go ahead, and I saw other things here. So.
Thank you very much. We also have new advancements. These are the new technologies that are coming across. For example, here we are just having a structure which is made up of a material that can allow radiation to pass through. For example, here. I'm so sorry for the past. Basically, these are just the materials. This is a material which can allow radiations to pass through, depending on whichever material. These are just new advancements. Then we also have another one here. Here you just put your crops or your materials inside, and you pump. You just pass in hot air direct. The disadvantage with this method is that there is a tendency of materials to overdry, which is not suitable for germination, because if materials are very dry, you realize that they don't actually germinate. Oh, thanks for listening. Material questions.
You guys are mean. You wanted to finish when I know that you had something more. Okay, so if you got some questions, please.
Yes.
Yes, give it.
Thank you for your presentation. I would like to know whether wind is also a natural method of crop drying. And another question is, yes, you have given us two types of crop drying, an artificial and natural. Aren't there crops which do not need artificial crop drying or natural? Could you specify that these types of crops can be dried using natural methods or artificial?
Let me begin the second question. For example, if you have like yellow bananas, maybe if you know you can eat them when they are dried, then you can also apply those methods.
Okay.
Before you guys, are you sure that you can, you've ever eaten?
Okay, if we are mentioning crops, we are basically looking for the use of such crops. For example, if I'm processing like coffee, the need of coffee, you want it to grow or you want it to dry. So here we are talking about crop drying.
What is being raw? Because even dried coffee is raw if it is not yet roasted or not yet processed into.
Well, I don't know whether I said raw.
Okay, to put it
raw. I don't know
put it
which
clear.
one you meant.
Put it clear, there are some crops, some methods that are suitable for some crops, then there are those that cut across. Like maize, you can use this local natural method. But it depends on how much you have, because here we're looking at industrial work. In an industry, you have tons and tons of maize, you won't rely on putting it on the ground, that will require a lot of space and labor. So we look out for other methods that are effective and they can take, they're efficient enough. Like we talked of this one of driving steam into it.
Can you go back to, as you explained that, can you go back to that solar panel business? That image of the solar panel? There.
Yes.
Can you elaborate the purpose of the, because one of you said the heat from the panels goes to the crops, another one says we pump this heat into the crops. Can you try to be elaborate to us and tell us what is the purpose of these panels? What is the mechanism? Can you be a bit precise?
Basically, these are solar panels. And in between, we are having.
In between what and what?
After these solar panels, there is a layer which is composed of air. So what these solar panels do, they just convert sunlight into heat, which causes.
How? Because a solar panel is simply a PN junction, which when you get sunlight and it pops on, and I wouldn't have really liked you to present that version of the panel because you attended the training, so you should be able to know better. So when you have the sunlight, the photon is falling on, you emit off some electrons, and then you leave there vacancies called holes, and these holes start transporting electricity into the PN junction, and because you got multiple cells on a panel, then the current flows, and then you get electricity from a solar panel. So I don't know what you mean by heat in between the layer. All I think you should have researched is that these panels, this fleet of panels, is to give you electricity to run your fans, which fans probably will blow that heat you are talking about, or blow the air within your crops. So I would want you to go and do more research on how these panels are working. Remind me to talk about how you can get nice photographs. This photograph is a shame, you know. If you present such a diagram, it doesn't really look nice because it's faint, and you could get better diagrams on the internet. But I will explain on how that is done. So are we clear that they have to get a good explanation of the mechanism of these panels, or you have a clear one?
I think, just like they were explaining, they basically concentrated on using solar. But even crop drying, I think you can use electricity. So, like you said, the solar is mainly you are converting solar into electricity, and you are using that electricity, I think, in the drying. For example, when you are drying tea, you get the electricity and the tea is put on the beds, which beds are, I think they have electricity. It's the electricity that dries. I don't know what dries, but
I think I can use more light. Basically, solar energy is converted into thermal energy, which thermal energy is
not a panel cannot convert. I will be very clear. A solar panel cannot convert sunlight into thermal energy in this arrangement.
Maybe if you use a solar concentrator.
So the two of you it cannot. I want to be clear on this. A solar panel only converts the photons which are falling there, help to produce electricity. Maybe when you use that electricity to heat up something, produce the thermal energy. But as he's saying, if you have concentrators, parabolic concentrators, either in form of pipes, okay, in a lugogo shape, like how these things are shaped, and then in the middle here is where you are putting whatever medium you are using to collect the heat, fine. But for me, the thing I think was the mechanism on here is that you are generating electricity, just like we did one of the trainings, we had the pump. I don't know whether that's what you attended. So the electricity you get runs the fans, which will blow this heat into the system of the crops. But whether it is, because those panels of yours are clearly being put on top of the building, on the roof. And I don't know what else is under that roof that we are talking of, that thermal energy. So you have to read on that and expound on how it is done. The diagrams you showed, all of them show that you haven't been able to get skills on getting there, those things. So I will, this was just an opening to see and to teach each other, because if I say go read this and you just read, each one will read the thing in their way. But now that you have shared, life has become easier. So you too, every one of you has to read again. Now what I'll have to do is that you have to incorporate all these comments, and then you send a new version which I will change into PDF and put on the course for every one of you to read. You understand? So now I need to make a few comments on your thing. So like on these advantages, when we are doing the presentation, most times it is very tricky to, when you pop things here, for example, they struggled here and they said, you know, the covering, they did not tell us that this could be a panel, I'm not sure. I don't know why it is in the bush. So what is this?
Those are just like stands.
Stands for what? These two, what are they?
They are not solar panels.
Well, me, I'm just thinking the way they look like panels. What are these?
If you realize,
I am not going to realize. But
if you realize,
I will not
okay, let us.
Elia, we are here for us. We want you to tell us how to think. We are not going to realize, because each of us have different reality. We realize different. Okay, come again.
Yeah. Now, this material is attached to this layer, this top layer. So of course, when you are removing it,
So where is the bottom layer? Where is the bottom layer?
this is the bottom layer. This is like one. Then this one, if you want to remove this, you just move this. I don't know where that is.
No, neither. It is not clear here. It is not clear how you explain it. Because if
you want to move this cover,
if this no, gentlemen and ladies, the concept of learning is to make sure that you say what you know, what you don't know, you go and look at it. Okay. That is those are the basics of being a good teacher. To be always willing to learn and say what you know and leave what you. Because I don't see why this corner here will only depend on this strap here. And if you logically, if you use dimensions and scale, and you look at the distance from here to here, and you look from the distance from here to here, this thing is too large just to be a strap where you lock this other cover.
It looks like a banner.
So I think you understand what I'm talking about. So you can have a seat. You will read about it and go back to the image and actually understand what the image is. Okay. So if you go to this place, everyone who is trying to follow your presentation will quickly look at the things and say, oh, for easy preservation, then they start being on their phones. If you are in an international conference or you are presenting to people who were paid to come and be presented to, they don't care. They think that they are being begged to be attending. So what you do normally is that you can make this animated and make sure things appear in order. So don't do that, those who haven't presented. Don't do that because you will come here and start fidgeting. So what I will do is to select these all stuffs, and then I go to where there are animations, and then I say appear, and when I say appear, I should be having a difference. So I am from this other part here. I say, you've talked, you know, we drive them, but you know, we have to build all these things, but nevertheless, we have some advantages of crop drying. So everyone is guessing, what are these advantages? So that's how you capture your audience. But if you come and slam them, boom, everyone reads to know and say, we thought we had some sense. So then you go on and say, by the way, if we want to preserve our crops, we need the crop dryer because we may lose out the seeds, we may even give them out for feeding for schools, but we may need them for another season when the maize season has gone across. And then you say, and some of the crops cannot be eaten raw. You need to dry them up in order to eat them and they feel nice, like rice or wheat, otherwise you wouldn't be. And then you say, and some grains like sorghum and the like, if you do not dry them and you pile them up, they will get rotten or eaten by whatever. So everyone just keeps wondering, what is the next advantage? What is the next advantage? And by the time you finish all the advantages, I think your battery has enough, then you will be able to, but I was, it's okay, I already made the key points on the thing. So, where necessary, make sure that you have something which is chronological, something that makes more sense. Now, on the before I bring the other group, is that I want to make sure that I show you a little bit of how you get nice images. You shouldn't get images which look fake. So I will. Like when I was training the colleagues, we were looking for images of this. When I asked one of the colleagues in sports science, I said, you can add a sportsman in your course just to entice your student, because his course is aerobics and dancing. So we had to look for a dancing lady. But now, for example, you guys who were fidgeting with fake diagrams, I call them fake because I'm not sure whether I will be on the internet. If I happen to log into internet, I'll be able to show you that you can get a bunch of images about crop drying that are a million of them, and you wouldn't imagine that you should have gotten this kind of images. Let's see whether I can get to the internet. If I can't, because my net cannot make corners. Nevertheless, if I can't get the image, I'll show you a few animations. Like for example here, this is where we are looking for a dancing sportsman. So all these images were available. Now in order to get this dancing girl, we had to, you right click and choose to open in a new tab or a new window, depending on how many things you want to open. Then when you open it in a new tab, it will come as an image. For example, as this image. The net, I don't have the net here, so if it came out as this image, there will appear something here, which is called view image. There will be two boxes here. One view image. I'm not on the internet, so okay, it seems to show that it is coming, but it was not showing at all. So once you say view image, it means you get the big full resolution image. Once you get a full resolution image, then you'll be able to add it into your work, and then you would have nice and beautiful things. Pardon? You've seen my password? Yeah. How many dots? That the man was on an ATM, so he saw another man entering, he did like this. Then when the man finished, he said, I've seen your password. He said, what did you see? 4 dots. So we want to look at crop drying images. That's what I'm searching, and I'll get beautiful images of crop drying, more better than what you were trying to show us, free of charge. Images for crop drying, and very beautiful, very illustrative, showing what is going on than the images you are trying to show us, which look faint. And this is the reason why I'm always tough on you. You spend time here, you can't use the available resources to learn, but when you are in town, you are like this. Yesterday I wanted to box these boys who were distributing Manilas for FDC. I said, why do you break our pavement to get stones and put these Manilas here? The young man said, but this is how we can reach people. I said, but when you put a Facebook picture, you can know how many have seen it and liked it. He said, but how do I reach you? But I've already been annoyed. So I should have asked him, am I a voter? So you see, these are beautiful. They look beautiful. They show the processes which are going on. The panels are here. The tank is here. I don't know what is in it. And surely, how do you have all these images and the types of crops? When you are talking of crops and grains, you would have such a photo. So I said you go to open in a new tab, and when you say open in a new tab, it is going to open when it is clear. So that when you paste it into your PowerPoint, it will be better. I told you there are 2 buttons here, visit page and view page. So view image. So you view the image. This one will give you the actual size of the photo which was uploaded at the beginning on the website. It is in a Google search, but now it will take you to the original photo, which is on the particular website. And once you have seen that image, you right-click it, then say Save As. As it opens, we can do other things. And I'm opening tabs to make sure that when I'm doing other stuff, I do not have to wait until when the image loads, then I click again for other things. You can have multitasking. As this is loading, you are doing other business. So now, like for example, these people are a bit mean. They don't want me to see so these are types of crops. They may look better after. And can you imagine? There are too many diagrams. Some will even, for example, the concentrator is here. This is a type of a concentrator. You are having all the heat concentrated here, and then you're able to dry these things. So heat comes, and the heat bounces there, and then this is where you put your things so that they are dried both up here and below. And I will go down to show you how many diagrams really you can access. You see, all these, there are thousands of images that concern crop drying. And you had a fake lady who wasn't even visible. Here is a nice lady trying to dry her things, her crops. And then view image. My computer is a little bit slow, but I don't know why it took me all this side, because I had asked for it to show me the image. Definitely my computer is, so like, I think these are onions. I mean, the photos you always see me presenting on moon viewing, I cannot draw them. So I go to Google, get them, or go to Facebook when I'm just browsing around the Facebook timeline when NASA has put the new technology, the photos of the astronauts doing space work. I pick one, put in my moon viewing presentation and update it. I don't have time to draw those diagrams or those animations. People did it, why should I hustle? Okay? So, the other group, are you going to use your computer or?
Yeah.
Yes, so bring it. I will make comments about these things later because they are just still trying to show up. I'll try to make the woman bigger. I hope it doesn't need a special comment. Here's the pointer. So I'm sure these guys will be so quick, and so that we will not enter into our answer.
Yes, good afternoon, members. We are group number 3, and our research topic was concerning power connections. We mainly looked at power connections in industrial settings, and the group members are, as shown on the screen. So where Ms. Opio Godfrey, Senikwana Francis, Batalingaya Agilio, and Bayanda Joseph. And as I told you, our topic was power connections. Generally, for us to have our industries, because we looked at it in an industrial setting as the question required us, and our concern was in an industry, we know we need power, but where does this power come from? So we had to look at where this power is generated before it reaches the industry or the factory where it is going to be connected. And we realized that for this power to reach the industry, we needed a grid, or which a grid refers to an interconnected network. An interconnected network between the suppliers and consumers of power, of which this time around our consumers are the industry or the factory that we are going to connect. We realized that power connection, all power was started being generated very many years ago. Like in 1831, we realized that Michael Faraday devised a machine
that generated electricity from rotary motion, that it took 50 years for the technology to reach reach a commercially viable state that was being popular and maybe used by very many people. And in 1878, realized Thomas Edison developed and sold a viable replacement for gas lighting and heating using locally generated and distributed direct current or electricity. Because we realized most of the industries by then, most of the equipment that were designed by then were using direct current reading. By then the technology of AC or the alternating current wasn't yet there. Like in this diagram we have power being generated by very many sources, but it has to be power being generated and just be transported to the grid and then supplied to the what? The industry. Like we have here the hydroelectric plant. It is generated, but then after it has to be transferred using the grid to the various industries. So you have this is the source, you have this is an industry, and this is an industry, and realize that the power is transported at an extra high voltage. Reason being, we have very many losses as a result of transportation. So the reason that's why we do that, we put it at a high voltage to minimize the power losses. I think you remember from your physics, the power losses during transmission due to the resistance of maybe cables and so on. So we also have power from different sources, like we have wind, we have wind generating plants, and we have even the industries themselves, they do generate power. But for this power to be used within them, there must be connections and what? And then they are also connected to the grid and then supplied to the industries. An example, for instance, if you have been to Kakira Sugar Works, Kibimba Rice Scheme, you realize that those people, though they have external sources of power, but they also have their power generated from within the industrial setting and it's being used within the industry. But for them to use that power, they must have the connections. So I would look at the history of direct current and realize that most of the devices by then were using direct current, that is in 1870s and 80s, and realize that small systems were sold to factories around the world, both in urban areas and remote underdeveloped areas for industrial mining or use. And this was measured by Thomas Edison, who discovered DC powered systems, and the systems powered factories and small downtown areas, but did not reach 95% of the residents. And I think this was the device. This was a DC motor that was designed by then that was used to generate the electricity. Though we don't like study it like theoretically in physics about the DC motors, this is simple, they have one core structure how it works. Then the first method used to power both the DC and AC generation plants were coal-fired steam engines and hydro power plants. Since most industrial cities were already located at waterfalls or rapids, utilizing traditional milk power, it was natural to convert to hydro electricity. For instance, currently we have very many industries located in different places. You find that, like for instance, in Kampala we have the Mkwano industries, we have the Coca-Cola, those people all need power, but power is generated from Jinja. So that power has to be transported from Jinja and through cables or whatever means and has to reach Kampala before connections are made to the industries. But by then we realized that it was costly, like for coal, it was costly and expensive, so means had to be devised, and then power was then mostly was transported using the high voltage DC power, which was the first method of transmitting electric power over distance. But we realized that using this high voltage DC current, much of the power is lost. So what was devised was using the alternating current and provide a solution to the distance transmission, and realized it also provide a solution to interconnect generation sites. Like for instance, if we realize, like what I was saying, that generation sites, you realize that maybe the supply is not enough. Like the Kakira Sugar Works, you find that it is having the external sources and also has its own power. So it can make interconnection between the two power points, and then enough supply is made for the industries. Then most of them are historical. I'll just be brief about them. The world's first public electricity supply was provided in the late 1881 when the streets of Saretam of Golda Mill in the UK were lit with electric light. The system was powered from a water wheel on a river well, which drove cement alterators that supplied a number of arc lamps within the town. Then in 1880, we had Edison opening the world's first steam-powered electricity generating station at Holborn Viaduct in London, where he had entered into agreement with the City Corporation to provide a 3 months provide street lighting. In time, he had supplied a number of local consumers with electric light. The method of supply still was using direct current. Then it was later on the year in September 1882 that he opened the Pearl Street Power Station in New York City, and again it was DC supply. It was for this reason that generation was close to on the consumer's premises. Edison had no means of voltage conversion, so the voltage chosen for any electrical system is a compromise. So increasing the voltage increases the current, therefore reduces the required wire thickness. That's, I think, very obvious from our physics that we do nowadays when we begin talking about the resistance and the voltage relationship during power transmission. Then we see 1880 as introduction of AC in Europe and the US. AC power had an advantage in that transformers installed at power stations would be used to raise power voltage from generators and transformers at local substations. Like if I can take you back in this, realize that the power is being transmitted from the sources at high voltages, but these industries don't consume all the power that is transmitted. So we need the transformers to step down this power to the amount that the industry actually requires for consumption, because again too much power is also dangerous because it can cause damage to the equipment which are deployed at the industries. So with the advancement in technology, there have been very many advancements in the field of energy, which I talked before. That is very many other sources that generates power that is used within the industrial settings, and realize that to make use of such power by industries, connections need to be done by a qualified electrician, because you cannot get any person who knows about electricity and maybe to go and do the wiring for an industry, because there are very many considerations that you have to make sure that the devices are working and they are well done. Because we realize that in this industry or factories, we have very many gadgets. We have gadgets which use direct current, and we have gadgets which use alternating current. So it must be done by a qualified person who is able to analyze and make sure that proper connections are made. So I'll take you through the first step, then my colleagues will take you in the rest of the procedures. And realize we are saying that to make use of such power, connections need to be done by a qualified electrician who links the industry with the power source, which requires serious considerations to avoid many dangers associated with poor connections, which include the following. So these are the steps. And the first one is we have to make a survey. You cannot just come from the bureau and say, I'm going to wire an industry. We must have construction plans. Like that always happens, even if you're constructing a building, you must have a plan. Look at the location. So after the electrician has been awarded under contract, he must inspect the site plans to determine the approximate location of the industrial building on the site, as well as the location of the underground wiring, raceways and manholes. Because as we realize, the wiring at an industry, we don't only have maybe overhead cables, but have underground cables or transmission lines. So we must make consideration and realize where are the connections going to be. And that one is always done by visiting the site in advance and checking the proper places where the wiring and connections are going to take place. Then the other thing is that he needs the electrician or the person who is going to that job needs to know the different types of electrical systems to be installed apart from the buildings only, because we have very many devices. We have processing machines, we have all kinds of things which are used within an industry or a factory. For instance, if you look at, I will give an example of Kakira Sugar Works. Still, you realize that there are plants, maybe you have the machineries for processing, you have the outside the machineries maybe for all those kinds of activities that take place. So you must know those gadgets and know their ratings, the power ratings, how the the amount of power they consume, so that we ensure that as it's going to do, make sure that proper sizing or wiring requirements are done. Because we know that sometimes you may end up using wires which are small and they may not support the high voltage that is required by the system. So you must take those things in consideration. Then testing the site for conducting requirements, that is most especially for purposes of earthing. We realize that these industries, they operate at at high voltages, and always we have too much, always even excess charges accumulated, and as well, always when wiring is taking place, always there is earthing taking place to avoid the excess voltages. Still, on top of the excess voltages, we have these industries as a result of very many mechanical processes. You find that there are some external charges which are induced. Like for instance, where you find that there are some belts which are used maybe for applying mechanical forces to move the motors. You realize that there are some charges which are induced. So to reduce those charges, there must be earthing. And we're saying that this earthing must be considered because we realize that the grounds, they have got very many different conductivities varying from place to place. So what has to be done is the electrician or the person concerned must make sure that the places are investigated and realize where am I going to apply my earthings from for safety. Because you may apply earthing in a particular place which is not all that conductive and realize that there is leakage of power which might be again dangerous to the community and as well as the workers. So I think, thank you for listening. My friend can pick up from there.
As we have been told by the colleague, the qualified technicians have to survey the area, and after surveying, getting to know where the construction is situated, getting to the equipment that is to be used, and also testing the ground, they again start in the process of installing and connection. Now this involves bringing up the equipment together, and so that you can, the industry or the factory can start functioning using the power without any fault. Some of these devices use direct current and others use alternating current, but as we have been told, most of them use high power voltages or they use high power. That's why we need qualified technicians to avoid maybe like shocks if a housing or a conducting surface of a machine becomes live due to a given fault. Power connection is normally done using cables varying sizes depending on the amount of power demanded by the particular load. This is so because sometimes when the small cables are used to transmit much power, they end up burning, which may lead to a fault. That is, the surface of the machine can become instead live, which can lead to a shock. And remember, if it is high power, automatically resulting into death. Then there are various connections used in the industries. That is, they normally use underground connections or overhead connections. Overhead connections are normally used by low power consumers, like we ask. But when we turn to industries, they can use overhead, but using electrical grids, we can transmit high power to the industries. Then we as consumers, households who use low power. Then we also have the overhead connection. That one involves using cables, and it is more suitable or good for those industries that do use high power, because chances of shocks are more reduced and there is earthing. As we have been talking about earthing, earthing is just a safety measure, as it is being talked about. The earthing of electrical imprints is a protective measure designed to protect us from electrical shocks by preventing the exposed conductive parts of the equipment from becoming live. That is, if any faults occur, like an insulator getting off a wire and becomes in contact with the body of a machine that can lead to a shock. And then the exposed conductors, the conductive parts are things like the metal container housings, the cabinets, the control circuits, the metal tracking carrier cable from the cabinet to the machine, and the machine itself.
That is what we have been talking about. In order to prevent that, it has to be surveyed by the qualified electrical technician to avoid dangers. Then I have a colleague to talk about the dangers of electrical power.
Right, once more, good afternoon, colleagues. Yeah, having heard from my colleagues who have talked about some background and what to do in order to have power correctly installed or connected to the industry, we can now go ahead and look at the dangers that are associated with poor power connections. Not necessarily poor power connections, but let's say in general power connections. So we can have the first one is electric shock. This is something you can always think of whenever you hear of power. You have to take care that there could be any live wire anywhere, and you can get shocked. There are very many things that can be, that can come from the shock. So the other one is explosions and fires. You've heard of very many instances, not necessarily industries, but in schools. There was a time school fires were very many, and everyone was asking the question, what should have been the causes of fire? But some of such fires were as a result of the poor power connections. And so it explodes and the whole thing burns up the building. Then the other one is sensitive flammable atmospheres. You know some other industries, like when you talk of when you go to the chemical plants where we have various compounds manufactured and they are actually flammable. So they have their atmospheres flammable. So there is need to take some good measurements of controlling such flammable atmosphere to get into contact with the power that can easily spark off the fires. Now, accumulation of excess charges, my friend Honora has been talking, hinted on that. He was talking of some possibilities of running belts and the likes, and they can also be a danger. So it is a hazard. The other one is short circuits. We all know what short circuits are. So therefore, poor power connections can lead to short circuits. And at the end of one time I was at home and a neighbor was short circuiting from the other room, and the rest of the building, this side, did not have what? Failed to have power. So in that case, if it so happens to be that it's an industry, then you will definitely have the power stopping to do what? You get a power, maybe let's say, we used to call it those days load shedding, but I should say it just goes off and everything comes to and standstill. Heating off, conducting and insulating materials from the, you well know that when current goes through any material, literally it's meant to heat up. But of course, the degree of heating depends on the type of what? The conductor. So there is need to take care of which. So, if you use small conductors, then in that case you will have heating, so much heating. And the insulator can also, may also at times not withstand what? The heat, and that is also a danger. It can as well damage the machinery due to what? Due to high voltages. If you have maybe there are some people who have always gambled and they end up just feeding power into something, and the moment you turn on, the thing blows up. So these are dangers due to high voltages. Fire breakouts, this one has reappeared, but I said it a little. Now, they may also, the poor power connections may also result into little or no power supply, which may affect the running of of the machinery. I've already said that. Power blackouts due to improper wiring. Now, improper wiring, one time when I was young, we were renting, and this man is telling us that this house, I don't want to see anyone using a coil, because the kind of wiring we have used cannot do what? Support a coil. And I was asking myself, but some other places we use, people use coils and there is no problem. So it was later on that I found out that it depends on the kind of wiring. So in this case, that is why it has to be a given kind of wiring for an industry to run, because not just any wire can supply power to an industry. Then we have proper remedy, possible remedies or solutions to such problems. Proper wiring should be done correctly and in time. That is a little self-explanatory. Good insulation should be ensured to reduce on the amounts of electric shock. Make sure that the cables used. That is why, the colleague was talking of either overhead or underground connections. That's why most of the industries, they have power bringing, they bring power to up to almost all inside the industry. But then when it comes to taking it inside, they have cables running from the poles through the ground to enter the what? That is enhancing on that. And if you looked at those cables, they have either thick plastic or thick rubber. So that is the kind of insulation I'm talking about. Then proper grounding, you need an earthing, and it should be a proper one. I was talking of you may put it in a place that is not good as such, but we need to do investigations and find out the good ground for the earthing. The other one is we need to have fire extinguishers. We are lucky we have one there just in case fire broke up from here. We can access one and have the thing turned off. Ensure exact wiring. Wires are used during installation to avoid overloading. I talked about proper wires. Flammables should be kept away from areas where charges are always induced so as to avoid explosions and fires. Now, in such industries like that manufacture chemicals, at least you have to have them manufactured and kept to some other safer places to avoid the electrification of the what? Having the atmosphere all all filled with the flammables that can catch on fire anytime. Then we're also saying caution should be taken about naked live wires. You've always had, you've seen different posters when the power distribution, it changes from UEB to UETCL, something of the sort. They are always putting up posters to advise people to avoid any places where they see like a broken wire and it is down, possibly in a pool of water. They are always telling us to avoid such places. And so in case of you see naked wiring, then you need to avoid such a place. Then use of voltage relays and dischargers to coordinate the protective systems. So we use voltage relays and dischargers. Now the discharger, as in kind of where we have a charge that has built up, there can be a way you can set up to discharge such a what? Such a charge, such that the atmosphere around that point is safe. Use of sensors and mechanical or electrical components in the installation's protective systems. And there are some equipment that I know you place them in a socket, but they have alarm systems. In that, in case danger is detected anywhere in the system, then the thing can always do what? Can give alarm, and in that case, you are in position to prepare for any danger which is almost coming. Color codes or other suitable provisions to avoid misidentification of wires. If you open these things, there are various colors there. Some always say red is light, black is this, so the color codes or the color for the wirings is used to tell that this is such and such a wire and the other is that such that you cannot have them mixed up. Protective equipment against separation of circuits as different voltages. Adequate air gaps must be maintained. That is why when you see in the power transportation, there has to be a given distance from one wire to another one. So even then, even in our industry setting, you don't just have to put them near. In most cases, if you travel through different, on certain highways, and you see that a little somehow, there are some twistings that come in a way that they a little bring these wires closer. I've always seen they attach something like a brick which is heavy and bring it on one wire such that they bring it down to have that distance increase. I don't know if you've seen such things. These are particularly important for, this one is misplaced, sorry for that. Installations, actually the two paragraphs are misplaced, sorry for that. Equipment providing protection against rain, maybe side splashes or full immersion, is available ideally. So such it's meant to be availed. Equipment that provides protection against rain and side splashes should be availed to what? To an industry. The equipment should be enclosed, insulated and corrosion proof. Metallic enclosures must be grounded. The mechanism of failure in these wet environments is the same as that observed in humid atmospheres. But
are you going to read for us and then after that explain to us? I've been patient enough. You are reading for us what is on the PowerPoint and then you take another time explaining to us what you have read. Haven't I been patient enough? Really, I have tried. If you have seen me, I have tried to walk around and compress myself, but you can't read for us and again start explaining to us. And I said it from the first PowerPoint, these are powerful points. I know you couldn't change, but when you say there should be equipment that should be provided, and the mechanism of failure in these wet environments is same as observed in humid atmospheres, and you rush through. It's your work. You can't read word by word, and then pause and explain to us how these things are, and then look for another point if it's misplaced. Another one is misplaced, and then you move on. We are hungry. I'm sorry, I was patient enough. So try, and I see. I wanted to leave you, but no, when you started reading, I said I have to express my hunger. Keep going.
all right. This is just a bit of information outside the dangers and the remedies. We are saying that most industries use power that is generated from hydroelectric plants, but then we can also have various other sources of power. And a case in point is wind energies. We can use turbines to tap that energy. We can use also generator to give power. We have solar energy that is tapped using photovoltaic panels, and there are also steam chambers. Now then the other thing is I just wanted to show us that the kind of wiring for an industry is not just any wiring. As you can see, if you went and opened the meter box back at home, you'll find out that it is something very small, maybe assuming it's only this one, but when you look at this is this is a box for power to an industry. You can see the thing is big and the kind of wires are not just, and you can see different wires running from different places to other places. And that is just another view of some other industry, and that is our end.
Yes. Okay, so we did we do lunchtime. I have a couple of comments. You couldn't change much, but if you realize on their PowerPoint, really, their PowerPoint almost, I think, looks like your writer. Just copy paste, and then you make slides. A PowerPoint should be having your powerful points. I don't know whether I wanted to go to the beginning, see the summary or the introduction, whatever Lolo was calling it. So look at the background, and the background is congested, and he was reading word by word. Now I don't know how the other group is going to present. There are 40 slides, even if you took 1 minute, those are 40 minutes. I mean 1 second, those are still 40 seconds. But are you willing for us to present, and everyone has presented? So I will make comments. You got your own computer, or I can flash it here. I still feel you don't read for us. And try to know that we are hungry, so that we go. But you guys have to really, maybe I may make comments on Tuesday, but you need to, I appreciate the way we are looking at the power connections in the sense of Kachira and the like, but this is about how is the power connected, at least from the corner or where the meter box or where from the joint up to within the industry. That's the kind of feeling I want you to realize. When you are in an industry setup, where should be the connections come from? How should it look like? And why should it be there? Should it be within an industry or somehow a bit isolated from the main building of the industry? So you need to look at that. And, but mine now for this session, my interest is about showing you how to present your work, how to collect your information, and how to make it more practical. Because as industrialists, if you happen to become an investor and you want to tell the government to give you land to make an industry on it, then you must be able to be very versatile, as in convincing. And also when you go to an industry to ask for a job, you should be able to tell them exactly what their industry does and the value you are going to add in their industry. If you go to a place and you do the same things they have been doing, you are useless. They could still go on with their own employees. But if you come with a new thing, then life becomes easy. So please, run through your thing so that we have at least an understanding of each of us. Afternoon members. My group members are Swabula, Ahabwe, Mwanguzi, and Aiseman. We are going to present about ventilation and air circulation. Ventilation basically is the process of changing or replacing air in any space to control temperature, bad odors will have smoke, dust, and reducing the amount of carbon dioxide in the environment. Ventilation is not only about the exchange of air between the environment and the place where we are living, but also concerned with air circulation. Ventilation takes two forms, mechanical and natural. Mechanical, we might refer to it as artificial. So, next is my background. Ventilation can't be attributed to any date. There is no specific date assigned to the start of ventilation. But as I mentioned earlier, we have natural and artificial. To start with natural, in the first place we have fireplaces. Ventilation started by man bringing fires indoors. This is basically by the start of industrial
we only had blacksmith activity. That's dealing with metals. So it required human beings to bring fires indoors. This is because of the rain that would disrupt the fires. So on bringing the fires indoors, we had heat and smoke increasing in the environment. So the need for ventilation began from there. And also early in Egypt, we know that civilization began from Egypt. Stone cavers, while doing their work, were disrupted by the amount of dust. So this also opened up the need for ventilation. Now, ventilation started with creating funny openings in the I should say, housing. Like many of you have seen glass houses. They always have funny openings at the back. So that was the start of ventilation. But here we say Romans under heating reduced on the need for open structures in our buildings. This began from distillation, the industry of distillation, brewing. So because it was illegal by then, people devised means of distilling from underground. So this reduced on the process, I should say, on ventilation. Not until in 1600 when King Charles passed a bill, I should say, or a law, stating ceilings should not be less than 10 feet and windows should be higher than their height. This was because of diseases. Like we know in those days we have epidemics. So these epidemics affected people and they could receive high numbers of patients. But these were airborne. So they had to increase on the ventilation, like ventilation per occupant. So King Charles mentioned that the ceiling should be 10 feet from the ground and the window should be higher than the height. We know that bad gases always rise up, as one of my members will mention about air circulation. And next in the 17th century, research began. This began with chemists. They started with testing insects placed in an enclosure, let's say bottles. Physicians, architects, and engineers. Physicians were concerned with the well-being of people, diseases, reduction of diseases, as well. But for architects and engineers, for them, they are concerned about the nature of the buildings, the artistic way they are supposed to appear. So on this side I'm having engineers, and this side I'm having physicians. In 1836, a Cornish mining engineer called Thomas Redgold published 7.2 meters every height per occupant. So this was the amount of ventilation required for any individual. And in 1775, a French chemist, Anthony, concluded that bad air was caused by excess carbon dioxide rather than reduction in oxygen. And in the US Greenland Civil War, that was 1853 and 1855, they re-established the value from 7.2 to 50 meters every height. This was because of the epidemics. Soldiers were wounded in this civil war, and later, for now, we are having it is at 27 meters every height. So, head towards artificial. The artificial oil/mechanical started in 1500 with Leonardo da Vinci driven fan. This was water driven. And next in the 19th century, we had steam driven and DC driven fans. They are called ducted fans. So, and by now we are having AC driven fans. So that's our background. Thank you for listening.
Thank you. I'm going to continue with our presentation and I talk about the advantages. Brief, just going fast through. It'll take around 1 minute, I think. So the advantage is that the first ventilation is to ensure safe and healthful working conditions for the workers. That is, the working conditions working in an enclosed hazardous of poor quality, air quality, which occurs as a result of factors like stagnant air that lead to the need for ventilation. Then the other one is to maintain acceptable levels for oxygen in air and to remove odors, moisture, and external pollutants. Then proper ventilation systems may eliminate the need for the use of additional respiration protective devices. Then high airflow rates for cooling and purging are possible, especially for natural ventilation. Then the need for ventilation, why is it that people needed ventilation was that the first one is they wanted quality air. So excess carbon dioxide in the air can cause occupants to feel tired, nauseous, and even lead to headaches. These effects can reduce the ability of occupants to work or learn depending upon the use of the building or the space where the ventilation is. Overheating, getting the right temperature of the building is important. Then there is efficient ventilation. Ventilation should allow controlled amounts of air in and out of the building using as little energy as possible. This as well goes hand in hand with reducing on the costs of putting up the ventilation. Then disadvantages of ventilation. There is one is ducting style will make it difficult to access the enclosed spaces. The ducting style is one of the is a style when, for example, we have ducted fans, and those ducted fans, they pull air from one direction, pushing it to another direction. So when those enclosed spaces are in a building, for example, for a local exhaust ventilation, it is very difficult because local exhaust is a type where you have those devices. They tap those bad pollutants before they get mixed with the air that people breathe. So when you are using those fans, it becomes very difficult to tap those pollutants before they mix with the air. Then it requires regular cleaning and maintenance of the ventilation devices. Then some ventilation devices do not completely remove contaminants or cannot be used for high toxic chemicals or large amounts of gases or vapors plus regular emissions, e.g. the emission. Then my colleague will talk about ventilation. Thank you.
Okay, as my colleague was saying, ventilation, it involves the exchange of air within the building or outside. Now I'm going to discuss the methods of ventilation, but I have said ventilation can be done. It can be forced, that is the artificial ventilation, or it can be done naturally. Under the methods of ventilation, we are going to concentrate most of the artificial or the mechanical or the forced ventilation. The first type that is the dilution ventilation, from the word diluting. That means that it involves like bringing in clean air such that you remove the contaminated air within a building. And then we are saying that time under the dilution ventilation, we say it can be used to reduce concentration of flammable fumes. But how do we remove them? How do we reduce them? By bringing in clean air to dilute the contaminated air. But you have to make sure that that's where we've noted that this type of ventilation does not eliminate exposure to gases over here. It does not eliminate, that means the room is going to be exposed to those gases. Then if you apply it, your aim is going to be bringing in the clean air such that the toxicity outside. How do we do that? By using exhausted, we've called them exhausted fans. They are the ones we use. But again, we are saying, like for example, if I use that diagram, we have like, take an example of maybe a bakery. We have said the whole process producing the fumes. We see the fumes moving up. Now, like we have inlets where cool air is entering. Now above we have the ventilators. So as the hot vapor moves up, it's going to go through the ventilators. Then in this one, the cool air now you're bringing in to remove the hot vapor. Now the arrows, wow. These arrows here, they're saying that if ventilation is not sufficient, the vapor will collect in the roof space to build back downward. Okay? that one is in case the ventilation is not sufficient. So you have to make sure that those ventilators are wide enough to allow the hot vapor to go through. Then another method, that is the local exhaust ventilation. And then we say this is the most method used by industry to ensure the health, as in the health of workers. Maybe some is going to talk about it.
Yeah, in this method of local exhaust ventilation, we find that we get a way of how we remove the impurities before they can be dispersed in the environment where we are working. So we get a mechanism of how we can trap them before they can spread in our working environment. And in doing that, we're even reducing on the costs of removing them, like in the previous methods of the dilution. It is very expensive. So this is the most effective one, which we can actually use. I'll give an illustration here, which shows that method very well. So when you look at this level, you find that we have shown this in the local exhausting method. You are working from a confined environment. So before those impurities that have poisonous gas and light come out, they are trapped here and they are led to the exit before they can spread within the environment. So you find that the people working within the factory, they can live in the same environment. This one, if you visit the new markets that are being made around and some industries, they are really making use of this. This is the first one that they talked of, but I want to just talk about this. So this is how best the local exhaust ventilation method can be used to control the hazardous substances within our working environment. Also, that's just an explanation which I have just said. People who do welding and cutting and aviating processes, especially in such industries, you find these are the people that especially use this method. They can, the welders or the burners, they put them as close as possible where the work is performed. So you find that the point where the work is performed becomes the trapping area of those gases. Examples, they have just given some examples. We have the ejected active fans, we have the blowers and the ejectors that are operated by compressed air. So they are saying this one operates on the that air moves from one area of high pressure to one area of low pressure. This is the mechanism of how that method works best to be able to trap those gases, the dangerous gases. From high pressure where they are concentrated, now they are taken to a place where they are low pressure, where people are not living. Then we have the radiant heating systems. In some industry, you find that those ones have so many things. We may have water heaters and boilers or pumps that are pumping water. So you find that the hot water that moves in the living area, heat is always delivered by radiators or slabs under the floor piping. Now in the process, we may be working in a very cool environment and still need warm air to be saturated. So that air is made hot, warm, and the environment in which we are working, where maybe there are lower air temperatures, can be warmed up and we work freely without any problem. Just talk about this is just showing you how air enters from the lower level and how air passes out via the windows to remove the contaminants. It's just similar to the previous diagram that we showed you. So you find that air enters from the lower level and the warmer air rises up or the contaminated air and it has to escape. So this illustration is just showing how air gets exited and how it enters. Now this place when there is no openings, you find that there will be no air entering. So you must make sure that the lower level are well suited to bring in the air. I'll give an example now, like in our windows, find that they should be made in such a way that air can freely flow in and the ventilation up should allow the exit of the contaminated air. So in that you find that the working environment will be safe, like we often highlighted the advantages. Lastly, I would love to just talk about the future prospects of what we ought to do to improve this process in our working environment of industries. We can design some techniques to cool areas or buildings better. And here we shall use solar designs. And so this is, some people have already, in the developed countries, industrialized areas, they have already begun this. However, here we are just trying to design some, we are just trying to borrow that technology, to use solar mechanism to cool our areas. But there is this one which is a prospect, sealed high performance grazing external window shading and core window coverage. These use double glazing and low emissivity. So you must make sure you know the power, the connection between the power and temperature. So if the emissivity is low, we find that we shall keep the temperatures, the power produced, which brings about the heat low within our environment. We are planning to bring in cool roofing application. These ones, how they reduce heat. You can have, I can call it a top, I'll combine this, a rooftop garden. You have your industry built, and now, irrespective of the building having a high space, reduce on the heat inside, you can put a garden on top to absorb all the radiation that come from the sun. That research is being done in Melbourne, and it shows that if you use the rooftop garden, 40% will decrease in the cooling load for spaces and the green leaf roof. So you have a green leaf roof on top of your industry, and is able to get all the radiations, and so heat will not be a problem within your working environment. So, lastly, we can reduce the heat generation and the lighting equipment. You can work in any environment whereby you just reduce the equipment that use heat, because whenever heat is produced, it is increased within the working environment. So you can bring in maybe daylight into the building using the natural radiation, or you can turn off unused computers that will bring about heat generation, or you upgrade the systems or other machines that use the electricity or the heat production. So that's what we had for that. We thank you for listening to us and for being patient and giving us your time for lunch.
Okay, so now you can thank them. You don't want to thank them. Okay, so I thought they would be quick, but then you tried. But again, you need to really arrange your stuff in a more palatable manner. In that you cannot give us advantages and disadvantages and then say what it is after. It becomes a little bit improper to work backwards. To remember, when you are presenting to the people. You are presenting to these people here, not to yourself, not to your friends, not to the board. So when you stand and start saying these are these diagrams, you should be able to present to the people and explain to them. That's when they know that you are presenting what you did or what you researched about, because you know what it is all about. I just want to make sure that, which group was it? This one?
Whereas one person defected.
I know. And I was always skeptical all along. And I can't fill the gap, I'll remain like that. So you spent too much time on the introduction. It could have been, yes, we would care where all these things came, but then on the comment I can make on on what you were doing about future prospects, we are not looking at your project or what you will do. We are looking at ventilation, how it is used in the industries. You understand? So maybe you can give suggestions of what you think the future industry or ventilation should be made, but you cannot say we are planning to. But if I may ask, where is Melbourne? In which country is it? Because you gave that the research is being done in Melbourne, and that shows about 40% increase. Where is Melbourne? Somewhere.
There is one.
Somewhere, because the others will have where is Melbourne? Are you sure? Anyone who can help us? Where is Melbourne? Is it a district? Is it a county? Is it a state or what? Where?
There is one in Israel, another in Australia.
So which one was which?
Australia.
Okay, this is how things work. You know, when you are presenting something and you are passionate about it and you want to give information and you want the people who are assessing your information to trust you, please know a few. What you call minor is what people use to knock you out. Because me, I saw Melbourne research. Yes. Is it a university? Is it a country? University. So, and in which place is it? And so if you just copy pasted from Google and download the thing, we normally get you from this part. So on that note, at least I am glad that you have now known how learning can be done by yourselves. One group gets this, comes and explains. My job is mostly to make sure that I put like moderation and seeing that what was presented is logical. I also show you how you can present it better. You are doing good, but some of the things could be made appear and disappear. So you make them appear as when you need them. So that when you are talking, people are not lousy. There are people who think they are smart. So when they scan through, they say, I don't need this. So you even keep those ones with you. So when they say, I knew this, but then what is he going to say again? You keep them on their tenors. On that note, I'm very hungry and tired because I'm not standing for long. We meet Tuesday, we finish the Leonard's number and do some examples, and then we move on, and then I'll look for another section on how to, another assignment. This assignment now will be tight. I'll time you. Today I just gave you a chance to make sure that you are able to give us what you did, and then I make comments. But next one will be tight. You have to make sure they are powerful points. You have to make sure that you do not read for us, you tell us what is going on. And I'm glad Knoxwell gave you an idea of what the presentation should be. And I think he learned a lot when he was always viewing the moon. That you don't need to hustle and read for people. Throw it there, talk your stuff. Those who want to listen, listen. Those who want to browse on the PowerPoint shouldn't waste your time. They should listen to you, and also you should have the content. You shouldn't start stammering around. Enjoy your lunch.